All right, people. We're going to talk about 3.2a. I'll go through this and kind of break it down for you because I think it's important, especially if you want to do well on 3.2b. You really got to make sure you did a good job on this one. So before we get going, I wanted to really quickly just do the thing you're going to use on every problem. You basically care about three formulas. Displacement, or sometimes it's height, is represented by S of t. Or if it's height, we usually write h of t. Physics, I think they use x sometimes. Velocity is written as v of t. They're functions of time. Okay. Now to find velocity, since velocity is a rate of change of your displacement, then you could have also written it as s prime of t. It's the derivative. The instantaneous velocity is the derivative of your distance or displacement. And then we have the third layer down, and that's acceleration. So if you look at the rate of change of your distance, we call it velocity or speed if it didn't have direction. And if you look at the rate of change of your rate of change, it's called acceleration. And we usually write that a of t. Now you can find this by finding the rate of change of this. Or if you wanted to get there directly, you could have taken the second derivative, the derivative of your distance. So you kind of have this hierarchy that we're going to use in every problem. If we have those three equations, then you have everything you need to solve the questions. You just have to, you basically are just going to have to say, okay, which formula am I using and which part do I plug in? So let's try it for this one. You're given your original equation. It's important to read this automobile distance from you as it goes around a racetrack. So imagine, racetrack, you're here, okay? The car's close to you, and then it gets farther away, and then it gets closer to you, right? So it's a changing thing. But if you were to somehow be able to have a rangefinder or measure the distance at any point in time, you could tell how far away it was from you, according to this equation. It says t is in seconds and distance is in meters for s of t. Okay, so I have my first equation. It's negative t squared plus 90t. And I would write a reminder that this is in meters. Okay, then I'm asked to write an equation for the car's velocity from you. How fast is it moving away from me, or how fast is it moving towards me? Because at some points it's like moving away, and other points it's moving toward. So that's just v of t, which is simply found by taking the derivative of this guy, which is, you get to use your shortcuts, right? You should be happy. What is your units here? Well, for velocity, if this was meters, we're dealing with seconds, it's meters per second. It's good to keep in mind. Now, acceleration is the derivative of that. So what's the derivative of this? Just negative 2. And the units on acceleration for this case is meters per second squared. Didn't ask you to put those on, but I like them there because it's going to help in my next question. How long until the car gets back to you on the track? Now this is a little bit of a sneaky question because back to you, you have to translate that in your brain. What does back to me mean? Well, back to me means when your distance away is 0. That's what back to you means to me. So all I got to do is set this equation to 0 and solve it. You could do quadratic formula, but the quickest way is to notice that it's factorable. You can take a t out of both pieces, and then you get two answers. T either equals 0 or 90 if you solve this part. 0 is not reasonable because it said back to you. I would imagine at times 0. That hasn't left you yet. So we're going to say 90, but word problems deserve word answers, so we're going to say 90 seconds. Because t is time, and time is in seconds in this problem. Not always, this problem though. I'm going to do D first and then come back to C. If it asks what's instantaneous velocity, that would be my derivative. Remember, derivatives find slope at a point. So I will use this equation, and I want to find the instantaneous velocity at 1 second and 5 seconds. That's basically like saying if you had a radar gun and you pointed it at the car after 1 second, what would its velocity going either towards you or away from you be? So I'm going to plug a 1 in here, and that looks like 88. Remember, you got to put units on it. 88 meters per second. That's at 1 second. That's its instantaneous speed. You can also do the same thing and find out its instantaneous velocity at 5 seconds. So we're going to do negative 2 times 5 plus 90. It's negative 10 plus 90, which is 80 meters per second. So it's kind of like slowing down in its ability to get away from you. So it doesn't mean it's coming towards you. It just means it's going away from you at a slower rate. So anyway, that's like having a radar gun. Now, what's average velocity from 1 to 5 seconds? This is what we used to think of as slope. All right, when you see average velocity, this is our old equation for slope, like y2 minus y1 over x2 minus x1. And it really is. You just need 2 points. Guess what one of the parts is? At 1 second, you are a certain amount of distance away. Because it's an average velocity is a rate of time, or a rate of change of distance. So I need to have the x part be my time and the y part be my distance. So I just need 2 points. I already have the 2 x parts of my points. I just need the 2 y parts. Well, how do you find them? I'll plug that in to s of t. The hard part of these problems is just coming up with, like, which equation do I use this time? Negative 1 squared plus 90 times 1, right? Which is 90 minus 1, 89. And we have, this is meters, right? And that's seconds. So 89 meters is what goes in this top one here, 89 meters. And that's 1 second, 5 seconds. And then you do it again for an s of 5. This is going to be a much bigger number. You have 5 squared, so it's negative 25, and it's 90 times 5, which escalates pretty quickly. And this one, if you type in your calculator, you're going to get 900 or 425 meters. So after 1 second, it's 89 meters away. After 5 seconds, it's 425 meters away. So it's going away pretty fast. But really, you just have your slope. You have your y minus y. So I'm going to go 425 meters minus 89 meters. That's y minus y over x minus x, which is 5 seconds minus 1 second. So you're going to have, I'm just going to go to the answer, type that in, and you're going to have 84 meters per second. Okay, so the average speed is 84. Your instantaneous speeds or velocities are 80 and 88. So it can tell you what the car is doing. It's more informative to know it was going away from me at 88 meters per second at 1 second, and now it's going away from me at 80 meters per second. So it must be like starting into the loop, where it's not traveling as far away from me at any time. That's more descriptive than just an average. Still the same average, but all right. So here we go. We're going to do this problem, and what I like to do off to the side, they gave me an equation about a silver dollar dropped from the World Trade Center. Oh, that's dated. Yowzas. I should probably change that question. Negative 16t squared plus 1350. That's the height. So a lot of times I'll write h of t. Just to remind myself it's height. And this is in feet. Okay, and then right below it I like to make an equation for velocity. So you drop a silver dollar. That's frowned upon, I think. negative 32t, and that goes away because the derivative of constant is 0. And acceleration is negative 32. And the units here are feet, feet per second squared. So now it says find the average velocity on the interval. That's t and t. Those are 2 times, time 1 and time 2. So that's just like the problem we just did. It's finding an average slope. So if I did that, I would say at 1 second, how many feet, what's my height? And at 2 seconds, yeah, that's what that one is. It's not a 5, those are S's. What's my height? So you can find that by plugging in. Negative 16 times 1 squared plus 1350, and negative 16 times 2 squared plus 1350. All right, let me pause while I do that so I don't waste time. All right, so I grabbed a calculator, did that, and I got 1334, did that, I got 1286. Then I did y minus y over x minus x, and I got a negative 48 feet per second. So that means it's falling down at a rate of 48 feet per second. That's what the negative is for. Part B wants you to find the instantaneous velocity at 1 and 2. So I'm basically using this equation. I'm going to plug a 1 in. I'm going to plug a 2 in. So at 1 second, you have a negative 32 feet per second. And at 2 seconds, you're going to have negative 64 feet per second. I think that's more descriptive than this. Does it still average out the same? Yeah, but you can tell this silver dollar is picking up some speed. I don't want to be under it. Okay. Part C, how long will it take to hit the ground? Hit the ground is fancy for saying height equals 0, right? So I'm going to plug in a 0 to my height equation. So sometimes you have to translate these. And you're, take the 16t to the other side, 16t squared. Divide by 16, and then take the square root. I'll try to do that in 2 steps so I have enough room to write my answer. You get a time of 9.19. It's actually plus or minus, but I can't really go negative time, so I mean, that's time travel. If I could time travel, I wouldn't tell you guys about it. And then part D is what's the velocity when it hits the ground? So, oh man, I wasn't on screen for that. Sorry about that, guys. I didn't look at my picture. So yeah, that's when I set it equals 0 and solved it. And it says, what was its velocity when it hit the ground? Well, here's when it hit the ground. So I just have to type in velocity of 9.19. So you're plugging into this equation again. So you can see you have to get pretty good at figuring out what equation you're on and not messing it up. So if I plug that in, you get negative 293.94 feet per second. That is cooking. I don't want to be hit by that. In fact, I'm going to look it up real quick and see how many miles per hour that is. Okay, quick Google search later. How many feet per second or miles per hour is 293 feet per second? It's almost 200 miles per hour. So yeah, you don't want to be hit by that that coin there. That would not be pleasant. All right, so that's that. I'll come back with the rest of it on a different video.